Hey, nice.
Hello.
So, hello. I am very, very pleased to be here today. Thank you for joining us. So, we are going to talk about test containers and how to simplify testing operation in an environment that is as much as possible close to the live environment that we are going to run. I am Gabri. I work right now in technical pre-sale. My background is a lot in development and also operation. And I'm really pleased to be here with Cora. Cora, would
Hi.
you like
Yeah.
to?
My name is Cora Iberclyde. I'm a developer advocate at VMware. And yeah, definitely one of my favorite things about my job is working with Gabri. So I always look for an opportunity to do
Thank you.
that. So here we are. I'm gonna do the first part of the presentation. And I know, okay, so I'm gonna share my screen. And okay, so the only thing is, I cannot, because I only have one monitor, I cannot see the chat. So Gabri, if you don't mind keeping an eye on the chat, and if somebody asks a question that you feel we should answer right away, just feel free to interrupt me.
Sure.
Awesome. So the topic of the day is ProdLike integration testing for distributed containerized applications. And okay, so yeah, I'm going to go a little fast because the presentation can't take more than an hour, and we want to stay under an hour. So we're going to talk about test containers. What are they? We're going to show an example for using them for database integration testing. Then we're going to talk about network affinity, how to make sure your environments are the same between dev, test, and production, and then we'll wrap up some takeaways. So what do we mean by production-like integration testing? So really we want to focus on integration tests, right? There's a lot of different tests you can do with your code, unit test, whatever other tests. So really we're focusing on these integration tests, which means that we're testing the points where our application interacts with some other system, another application, a database, anything outside, right? And what we want to do is have the greatest fidelity possible when we're testing to what we might encounter in production. And we want to shift that fidelity to even to your laptop, right? The ideal thing would be that if you're at your laptop and you're just testing your code locally, you have the greatest similarities, the greatest fidelity to what you are going to have in production, because then you can find all of the issues earlier, which is going to be easier to fix and less expensive in terms of time and money. So so we're going to do that today. Everything we're going to show you today is going to be something you can do on your laptop. So common approaches to doing this kind of like module to module integration testing. So we've seen over time, you can have a shared instance, right? A lot of teams have, this is our central database. Everybody can test against that. Or sometimes you kind of want to be more in control of your own environment. So you might install a database into your own environment. I remember like installing Oracle XE many years ago on my computer. And then things got a little bit easier, and suddenly we had like InMemory Solutions. So right in your application, as your application started up, it could start a database right inside of memory. You have this simulated sort of experience. You're not talking to something outside of your application, but at least you've got a database, and you don't have to set it up, install anything, or manage or maintain anything outside of your app. So InMemory Solutions are really convenient. But looking further into this option of in-memory testing, so we have some options, right? So there's like for you can for example have, especially I think the examples that we're giving really focus on the Java ecosystem, which is what we're most familiar with, I suppose, or me personally. Gabby has a little broader knowledge there, but the examples that we're dealing with here are a little bit oriented in Java. But so with whatever development framework you're working in, you might have slightly different options. But there's mock like web servers, things like WireMock or Loki, or you might have an in-memory database server, like in the Java world, H2, HSQL. And so that just starts up in your app and you can test against that. Really convenient. But they have limitations. First of all, they require framework support, right? So I'm just saying, I'm giving you some Java examples, but what if you're testing in Python? Which ones are available for Python and how mature are they? And there's also still behavioral differences, right? Like it's some process it could be a mock server, or it's usually some kind of like limited form of the fully featured product that you actually expect to interact with in production. And then you can't necessarily do all of the testing that you might want to do. You can do maybe some like latency or bandwidth testing with a mock server, but you might not be able to do all of that. Maybe network chaos testing that would really prove to you that your application is resilient. And then not every service is going to have that in-memory option, right? So not only is it important that your framework supports it, but like not everything has something that can start in memory. And then there's configuration differences, right? Security configuration, other things. So it's a good option, but it's not perfect. And because now we're all doing microservices, or it's more common, let's say, to do microservices, that means you have more applications and more interactions between applications. So there's more integration points to test. And also with the explosion of microservices, there's also been an explosion of service options, right? So what are like, before there was like a handful of databases we would use, right? Then there was like NoSQL databases. And then just this ecosystem started with, maybe these are some of the most common ones you might have heard of: Cassandra, Mongo, Redis, etc. And then, but if you look at the CFC and CNCF landscape, it's overwhelming. It's like literally overwhelming. So there's not going to be an in-memory option for all of these things. So one thing that really helps is containerization. Did I skip a slide? No. Okay. One thing that really helps is containerization, right? So as I'm describing this sort of history of like a shared instance or installing one yourself on your machine or using an in-memory instance, at the same time, there's also been advances in technology, and containerization has helped a lot. Right now, you can take a database. You don't have to actually install it onto your machine. You just can start it up on a container. So you've got Docker installed. You start up your MySQL database in a Docker container, and that's a lot easier than it was to install and maintain your MySQL instance. And if you have many of them, then you can use something like Docker Compose, and it'll start various services at a time. So those are good solutions. They're improvements, but it's still cumbersome to be managing the startup and the stop and the cleanup and all that stuff of those services. Even if it's easier to start them on Docker, you still are responsible for some of that lifecycle management, and it's still additional skills, right? This is you need to learn something that's outside of the focus maybe of what's really bringing value to your application, right? So it starts to feel a little bit like administrative operational work that you're doing just to be able to test something more faithfully. So thankfully, there's an even easier solution, which is what we're about to talk about today, which is Testcontainers. So this is easily for easy testing with external services. So it's great that you can containerize something and run it on Docker, but that managing of that is still hard. So Testcontainers make that management easier. They take care of that basically. So Testcontainers 101. If you're new to Testcontainers, they are they're a Java. So I'll define it as a Java library that creates an instance of a Docker container that you can test against. And for this Java library, it supports JUnit 4, JUnit 5, and Spock, these testing frameworks, right? The frameworks that you use to write your test code. It's not only for Java, though. I know. So the examples I'm going to give, as I said, are Java. But if you're not coding in Java, then go to the testcontainers.org website, go to their GitHub site, and you'll find that they have projects for Go, for Node, for various other languages. I think a few more than what I could fit on the screen. And you can see based on maybe the stars or how old they are, how mature each one of these is, but they definitely have options for other languages. So on their website, you can check what available modules there are. So these are the containers that they already have. This kind of like a curated, prepared list that you can very easily use. And you can see that on the list of modules on the second column here, there's things that are the most common, right? Like Kafka is very common, Nginx, Rabbit. Gabby's going to demo to you later, ToxiProxy. And within databases, there's so many different types of databases that you can also see a pretty wide list of databases. But if you don't see here the thing you want to work with, that's okay. Because, for example, for databases, there's also just JDBC support or R2DBC support. So you could use it with any database, really, or even just Docker Compose. So that can start anything you want. Or actually, there's a generic approach where you can also anything that can be run as a container can be managed by Testcontainers. So these are just like things that make it easier, but they're not necessary. As long as you can run it as a Docker container, Testcontainers can work with it. Okay, so then why and where to use them? So the reason is that you want to be testing against something that is most similar to production. So you want to be able to easily instantiate a service and also dispose of it easily, especially where you lack an in-memory option. And you want to be able to test against any application that can run as a container, right? Those are the places where you want to use them. And for integration testing, it could be maybe for like a data access layer, or if it's an application integration, or the browser-based acceptance, like they have like if you're doing Selenium-based testing, test containers also support that kind of testing. So all of those are good use cases for test containers. The idea, just a little bit of history, the idea initiated with this gist by Moshe Eshel, where he used a JUnit rule to start up a Docker container. And so after that inspired this project. And then by 2017, by the end of 2017, there's a comment in that gist that says this has been superseded by testcontainers.org. So that was the inspiration. Now, a little bit of syntax for the Java approach. It is an extension for JUnit 5. So in JUnit 4, it was a little more tightly coupled, and you used it with an @rule JUnit 4 annotation. But in JUnit 5, they kind of like reworked it, and JUnit 5 introduces these extensions that attach to the life cycle of a test, right? The life cycle of a test is, before all the tests, do this, and then before each test, do this thing, and then you run your test, and then you can do define what you want to happen after every single test, and then after all the tests, right? Those are the sort of the hooks that you have available to you in a JUnit lifecycle. So test containers can interject in all of these, and so this is basically an extension that intercepts the JUnit lifecycle events. So you have to annotate your class as @testcontainers in order to hook into these callbacks, and then for the object that represents your container, right? This is, for example, an object that's going to start a Postgres container on Docker. You annotate that with @container, or in JUnit 4, as I say, you would use rule or class rule, but you annotate that, and that tells test containers, hey, this is a container that I want you to manage. I want you to manage its lifecycle. I want you to start it. I want you to help me connect to it, and I want you to stop it when I'm done, right? So let's, in case folks are newer to JUnit, the test lifecycle, so you understand kind of like what test containers is doing at every stage. These are the different callbacks available. So as I mentioned, before all tests, before each test, after each test, after all tests, and then there's a couple of other callbacks there. But I want to focus on, okay, here's an example of a JUnit test. So you can see it's annotated with @testcontainers. And we also have our container here. So we've annotated with containers. So now test containers knows it has to manage the lifecycle of this object called container that is going to start a Docker image, right? And so if we were to execute this piece of code, what we would see in the log file is, first of all, the first thing that runs in the JUnit lifecycle is the thing that's annotated as @before all, right? Before you run any of my tests, do this. And so you see that all we're doing is logging something to the log file. And in fact, the result on the right-hand side is only that line logged to the log file. So we know test containers didn't do anything there. If you wanted to do something, you could extend, you could write that custom code and have test containers do something there. But by default, test containers has nothing to do with the before all. The next thing is, oh, wait, my battery is running out here. Sorry, I didn't notice it was unplugged. All right, we're good. Then in the constructor of the class, it just creates a new class. So that's just Java doing its thing. And then it's getting ready to, then test containers steps in, right? It's about to run the before each test. And for the test, you're going to need a container. So what it does, the very, very first time you start this up, it says, well, is Docker running? Because we're going to start these containers on Docker. So let me make sure that Docker is running. So it says, okay, I found Docker. Okay, I'm connecting to Docker. Great. And then it pulls down this image called Ryuk, and it starts that up first. And that's kind of like a utility that test containers uses to clean up the containers after it's done. So that's just sort of like an admin thing that test containers use it. So you'll see that running on your Docker daemon. And then it says, okay, well, which container is it that you want me to run? And so here we had coded my repo, my image. That could be something on Docker Hub or GCR or whatever you're using, Harbor. And so then it says, okay, let me pull down the Docker image you wanted. So now it's starting to manage, right, the lifecycle of this container. And it starts up an instance. So this is the ID of the instance that it starts. So when we get into the before each test method, you know that you have a container already ready for you. So at that point, it's already provided it for you. So here, if you looked at your Docker images, your Docker processes, you would already see that container running. So, okay, so then you can do whatever code you want in your before each. Then you run your test against Testcontainers. Has nothing to do with what you're doing in your test. You do your thing. And then after then it runs the after each. So you can run whatever code you need after your test. If you're doing cleanup or you're doing some analysis, that's you. And then after the after each runs, then this Riak container, this Riak process steps in and it cleans up. It removes that container that you used for test number 1. So you're clean, right? Then we have 2 tests here, actually, right? We're halfway through this file on the left here. Now we go into test public void test number 2. So it creates a new class instance, and then in the before each, it says, okay, well, I'm going to do a second test, so I'm going to need a second container. Now notice that here it doesn't do the whole like, is Docker running? Let me connect to Docker. Let me get my Riak assistant deployed. It doesn't have to do all the admin stuff. It just says we're all connected. Everything's good. I just need to start a new instance of my image that I'd already downloaded. So it starts a new instance. You can see the instance has a different ID, right? This one ended with C5. This one ends with A1. And so then you enter before each for test number 2. You can connect to that container, do your thing, run your code, clean up after yourself. And then after you're done with after of the second test, Riak steps in again and says, okay, let me clean up. So when the test ends, it's cleaned up after itself, right? There's no like trailing Docker container left over. By default, if you want that container left over to do analysis on it, you can tell Testcontainers, don't delete the container. But this is the default behavior. Now, so as we saw, for test 1, it started with 1 container. And for test 2, it started a different container. What if you don't want that? What if you know that whatever environment was created for test 1, either you want it for some reason for test 2, or you know that whatever happened in test 1 doesn't change the environment in a way that messes up test 2, right? Like you can maybe, if you had a table there, maybe you just truncate it. And so you can save time if you don't have to stop and start a new container. So you can just add the word static to that container. And this time, when you go through all these steps, notice that in the after each of test 1, it doesn't stop and restart the container. And if you compare the IDs of the container between test 1 and test 2, it's a different class. It does that, but we made the container static. So the ID of the container is the same in test 1 and test 2. And then Riak only removes the container at the end of step 2. So that's the interaction between Testcontainers and your JUnit test. So once you know that, you can use them pretty easily. So, okay, so I'm going to do a few demos. Okay, so this is what I showed you in slides. So let's do this one. This is a connection test. So what I just showed you is basically like how Testcontainers can start a container and then your test will run. But your test actually has to connect to that container, right? We haven't talked about how do you actually connect to that container. So let's talk about that. So here we're saying we're starting this container and this application, which I'm actually just borrowing, you can see here, I have a variable called HTTP bin image, and the value of that is, it's just an image that I like to test against. I didn't write it. It's just an app that's available on Docker Hub that just responds to like HTTP responses. So I'm just borrowing, I don't know Kenneth Reitz, but I'm really grateful that he wrote this because it's a great app. So that's what we're doing. So this is basically going to go to Docker Hub, download this image, start it up. And then I know from looking at this Docker Hub page or at the website where I got this, that this app, when it starts up, it listens on port 80. The container listens on port 80. So I'm telling Testcontainers, hey, I want you to create a container and it, it's listening on port 80. You need to expose port 80 so that I can talk to this container. Now, that might make you think, okay, well, that means that when the container is starting up, I can just go to localhost :80, which is not the case, right? Because 80 is the port that the container is listening on, but it's not the port on your host box that is mapping to that container. So what Testcontainers is going to do is when it starts this image for us, when it starts this image for us as a running container, it's going to map a port from your host to that port 80. So what you need to do is connect to that port that is dynamically mapped. And so you need to ask Testcontainers is, hey, what's that port that you just dynamically mapped? So here I have 2 tests running to show that if you just try this one, it's going to fail. We're expecting test 1 to fail. And in test 2, what you can do is take this object, this container object, and just call these methods on it. You can get the host, you can get the first mapped port, and that will work. So let's just show that running. Okay, so again, we're expecting test 1 to fail and test 2 to work. So test 1, perfect. Test 1 is failing because it says unknown host or something somewhere. Socket exception, can't connect. And the second one says, oh, great. And you can see here it connected to port 55014. So this was able to get the value of that first mapped port. And this is the expected response from the call that we're making. So that is how to connect. And then I mentioned, okay, well, here we created a container from something that we pulled from Docker Hub. But what if you just have an app yourself and you have a Dockerfile that can build that application? Because maybe what you actually want to do is use a Dockerfile to build an app that you're coding, and then start your app on the Docker daemon and run tests against your app as if you were a client. So then maybe it would be useful to just create the container from a Dockerfile. So that's what I'm going to show you here, which is, okay, so we're going to create a container again. This is of type generic container, creating an image from a Dockerfile. So now I have to tell it, where is this Dockerfile? So I'm saying this Dockerfile is in, where did I say? It's in this path, temp/hello world. Okay, so here I am. Let's make sure that's true. Here's my temp folder, and here's hello world. And in hello world, here's a Dockerfile. Oops, there's a Dockerfile. So what I'm telling it is go to temp, hello world, run this Dockerfile, so to produce a container out of this code right here, and then run that as a container. And I have other options. I can provide build arguments, or I can provide runtime environment variables. Again, I can expose ports. Here I'm choosing to expose 2 ports. I can define conditions, kind of like wait for it to be ready. I have a few options here, right? It's pretty flexible. So I'm just going to show, because we're using this to expose 2 ports, we're going to do a test to one port and a test to the other port just for fun. In the first one, we're going to use this get first mapped port approach that we used in the last example and call an endpoint called ping. And then in the second one, we're going to get mapped port to 8081. So this is how you get something that's not that first one. This is to our second one. And then we're calling a different endpoint called UUID. So let's run that and make sure that that works. So we can see here that, okay, great. It worked, and our first one worked, and our second one also worked. And and it built the image from the Dockerfile. So then container log says, okay, so that's great. So now we know we can create as long as we have a Dockerfile, we can make it work. So very flexible. But what if as we're testing, an error happens inside of the container, right? How do we get that? Right now, all of these logs are coming from the code on my machine, from the thing that we're using to test against the container. But what if the error happens inside the container? How do I get the log files out of the container? So there's a couple of ways to do it. So here's another example. I'm creating a container. I'm just going to use a base image called, what I'm using actually is when this Dockerfile ran, it downloaded a base OS image. So I'm just taking advantage of the fact that that's now on my machine. So this is just a plain OS image. It doesn't have an app on it. So what I'm going to do is say, when that container starts, run this command. So just using the shell, just run 2 echo commands. One echo is starting up with this environment variable, which I'm also providing here. So I expect it to say starting up with greeting equals hello world and publish that to standard out. And then I'm saying echo a second command that says, oops, something went wrong, and publish that to redirect it to standard error, right? So I'm simulating start up a container, write one message success, and write an error message. So now when I want to get that log out of the container, I can either just call the container and say, get the logs, and it'll get all that information. Or I can say, get all the logs that were written to standard out, or only the things that were written to standard error. And because I want to attach myself to the logs, I actually have to, in this case, start the container myself. So you'll notice that in order to prevent test containers from starting this container before I get a chance to do it, I did not annotate this one as at container, right? So Testcontainers doesn't actually know, has not been instructed to manage the lifecycle for startup, at least for this container. So I start it, I attach myself to get the logs, and then I'm going to show you how to get all the logs and then how to differentiate between success and error logs. So let me show you that one first, and then before I show you the slight variation on that. So container logs, let's run that. And okay, so this is what we ran. So here we said container logs all, right? Here is, if you just do a container get logs, you will see everything. So we see both lines that were echoed. If we say just get the logs for standard out, then we only see the good line, the success message. If we see get logs for standard error, then we see the message that's the error message. Now, this is fine, but wouldn't it be nicer if this was actually prefixed by, these prefixes that we have in our log files? It would probably be easier for analysis, for a parser, for, just visualizing, retaining the timestamp, etc. So for that, we have a slightly different option, which is we can use output streams and attach ourselves to a log consumer, like the SLF rate J log consumers, which you would normally use in a Java application, for example. And that result looks a bit different. You can say just follow it, right? So it's not getting it at the end, but rather it's following it as these messages are being written. You can add them. You can just stream them into your log file. So here we see these two messages right here with all the prefixes, but you can see also that one of them is info and one of them is error, because we said separate output streams. So we want it to differentiate between info and error. So it's retaining that information. So that's pretty powerful. And then let me just go back to the slides for a second. Okay, so that's test container basics. That's our 101. And then often we're using test containers. Probably the most common use case is to test against a database, right? And so it's important because comparing that in-memory option, the in-memory thing that you're using can be configured to behave like a system that you might expect, right? Like the in-memory wants to be like Postgres, for example. So it's Postgres-ish, but it's not really Postgres. And so there are going to be cases where it's going to behave differently than the real system. So I'll show you one more demo, and which is this. So we're going to use this in-memory database called H2. And you can see that we're trying to make it as much of Postgres as possible, right? It's the mode is Postgres. We have a dialect setting that's like Postgres again here. So we're trying to say, be like Postgres. And yet, this example is going to execute some SQL that we've included in our application, which I'll show you. It's going to execute this SQL. When it starts up the SQL database, the Postgres database, it's going to say create a table with an ID, a username, and a text. So if you imagine like a message board implementation, it might have ID, the username, and then the message that a person wants to write. And so let's say you wrote this application and you have a bunch of messages in your table and you're like, my table is getting really full, but I feel bad deleting messages that other people put in there. So what I want to do is actually improve my database model. And I want to add another column to my table called date of expiration, so that I can, people will know that their messages will only live for 30 days or 60 days or whatever. And so then I also am sort of giving myself permission to just clean up my table when that date of expiration arrives. So I want to alter my table, add this column, and then there's already messages in my table. What kind of date of expiration do I assign to those messages? Well, why don't I just say, take the current date and add 1 month to it? That should take care of it. Okay, now the problem is that this syntax, while it would work on Postgres, it actually doesn't work in the in-memory Postgres-like database that I'm using. And so I'll show you that. So let's run it. Here's our code that uses H2 in-memory database. This one, sorry. So let's run this one. So you might think, if you're a Postgres developer, you might think like, there's nothing wrong with my code here, and my SQL is perfect, right? It works. If I test it outside of the context of my Java application, I can run SQL directly against the database, and this SQL is fine. But my Java application is complaining about it. And the reason is that your in-memory instance of Postgres doesn't like it, right? It's here, it's complaining. It just doesn't like the syntax. So instead, if I don't use H2 for this particular test, right? You can use H2 for other tests, but for the integration test, if I say that I just want to use, so I'm making it I'm going to use Testcontainers, and I'm going to use I'm going to create a container that's actual Postgres. This is a real Postgres instance running on Docker. I don't change anything else. Then let's see if that would work. And that should work. Let's wait for it to finish. It's already working. You can see it's better. So that worked. Okay, so then I know that my SQL, which I thought was correct because I know Postgres, is correct, and now I can validate it. And I'm doing it right on my computer, right? I haven't had to wait for this testing to happen on some integration environment farther right on the chain. And just in case there are Java developers out there, I just want to point one more thing out, that in the previous examples, when we were connecting to a database on a port, we were doing a container.get port. In the case of a database, the Testcontainers is going to dynamically generate the JDBC URL, username, and a password. So you want to get those, even if you're not working in Java, you want to get those values so you can connect to the database. If you're working with Spring Boot, then Spring Boot has actually added this dynamic property source where you can take those values and feed them into the Spring properties that need those values, and that will dynamically pass them to Spring. So that's another cute little, a cool little sort of like integration there. And that's my part. So I'm going to hand it to Gabby, who's got fun stuff to talk about as well.
Thank you, Cora.
So let's see. I'm going to. So I think, Gabby, you have to share your screen.
Yes.
And then, yeah, and then we'll add it to the stream.
Okay, thank you very much. Can you see my network reliability slide?
Yeah.
Perfect. Then, Cora, there were a couple of questions. If you would like to add something, I didn't have access, unfortunately, to the chat, but I have great help over here in passing through my comments.
Awesome. Okay.
Okay, network reliability, yes, because your application is not only the code that you write, but is also all the network, the connectivity that needs to happen between your application and all the other services that eventually your code will need to talk to. So in general, which are the challenges in a real environment when it comes to networking? Well, we know that network can be configured differently. There can be problems with latency from one location to another location. There can be difference in the bandwidth that can be transmitted. Sometimes connection unexpectedly close, probably because the other application failed or because something happens in the middle. There can be changes in the packet size between like the standard packet size of the 1500 bytes or the 9K jumbo packet for Ethernet. And all of these changes will do something to the time that it takes from your connection to be established and eventually for you to receive the data. So now, how can you at least start to do some type of investigation? Do you need to change something in your application? Well, these challenges add more challenges to what you need to do, to the skills that you need to have. You now need to know everything about networking. Do you need to learn a lot of new information that not necessarily are the one that you can practice as a developer daily, thinking about business logic for the application and not about all the platform and in general, like the different layers that your application is going to use to run on. Do you need to learn new tools? Do you have to configure environments? Well, that of course is going to be pretty painful if you have to do something like that. Luckily enough, you can start simulating network condition in your directly in your environment using ToxiProxy. ToxiProxy is a framework that helps you simulating network condition, and it runs in particular as standalone, but also as part of Testcontainer. So there is ToxiProxy available directly as a module in Testcontainer. So it's going to be pretty easy to plug in exactly using all of those great things that Cora showed, like the methodology, the mechanism that you need to use. And it starts as a separate container, as we know, using our Docker demo. ToxiProxy, what it does is that it collects the traffic that needs to go from your application to another component, and you can configure to introduce some delays. You can change the bandwidth, the latency. You can add a jitter to simulate variancy in how all of these different variables will affect the traffic. And it's but it's not okay. There is proxy in the name. Is not a proxy. So let's not think about an HTTPS proxy or an HTTP proxy that will that it's going to be a different type of application. This one is specific to create to simulate a network type of disturbance for your application. It requires for your ToxiProxy, your application, and the container that you want to use, for example, a database that potentially lives on a totally different network respect to the one where your application will be deployed, to be on the same network. Well, how can we do that? Let's check. What is the network definition in Testcontainer? An application as we can use Testcontainer as an added library to our application to run different test containers that will run, for example, our Postgres database. We want to add ToxiProxy, great. So we also will need to run another container that runs ToxiProxy. And we also need now to introduce a new module that is the network. The network is the place where all our application, our ToxiProxy container, and our Postgres will be connected. In this way, what's going to happen is that the traffic, instead of going directly through the network to our Postgres, We are going to route our traffic to ToxiProxy, and we'll see how to do this. It's really easy, no extra language learning it's needed. The ToxiProxy then is the one that's going to mediate the traffic to our Postgres, and of course, then the traffic it's going to, I don't know why the animation doesn't work, right? It's going to go back to our application following the same path. So ToxiProxy has the possibility to do something with this traffic and simulate different aspects of our network. What if we need to have multiple containers that we want to run? For example, we need to talk both to a Postgres database and to a Redis instance. Well, we keep using our network and attaching our containers to this network. Let's look at a demo of what this means. So over here, I'm looking for which are the containers that are running in my Docker, and this is my test class that implements an interaction between my application, my message board application, and a Postgres database. But this time, I'm going to use a ToxiProxy container to simulate different network situation. Everything that Cora said before, of course, applies. Specifically, what we are going to do is that we are defining our network. And when we create our Postgres container, we are going to create this inside our network. Going to define alias for our proxy, but this doesn't really add anything to our specific part of the connectivity. This is, again, created on the same network. And we are going then to take our proxy from our ToxiProxy container. And we are going to bind this to the database. So now let's grab the connect, because when we create the ToxiProxy container, we are saying now we want to proxy the communication specifically on this port for this database. Now we are going then to build our string that contains the information that we need to connect to our JDBC URL. So of course, now we are going through the proxy to do this. So we'll take the proxy port that is exposed to talk with the database and so on, until we have our full URL that we can use to talk with the database. And let's do the first test. The first test, we just apply a plain connection from our application and retrieve messages that are running in the Postgres database. We are going through the proxy, but we are not really adding any delay or any toxic to this connection. And we can see that the application starts, does the query, and it finishes successfully, and everything is fine. Good. Now, what we want to do is, for example, that we want to introduce some changes in this network. We can, in this specific case, add some latency, 1 second of latency downstream, and we also change a jitter to be, we add a jitter of 500, half a second, so that we can change a little bit when this latency, how this latency is going to affect the connection. And then we do, in this case, I want to, for the sake of our demo, do something really quickly. I'm iterating on the same call for a few times just to see that I'm still able to maintain my standard behavior, even though there is potentially this latency applied, encountered during the communication. And I'm going to run my test. And over here, we can see how things get instantiated in Docker. So you can see how the containers are over there running. And again, looks like, well, we can do it, even if there is a little bit of delay in this connection. Now I want to do something more difficult. I want to cut the connection and see what happens. So specifically, so first of all, over here, I'm taking a little bit of time. I want to be sure that I'm not reusing one of the previous connection if eventually I'm running this test, one back to back with the other. And I am checking now that the exception is thrown if the connection is broken, and then anyway I have some fail-safe that we are adding over here just for a graceful end of the test. And so now we are running this one, and what will happen is that we start the connection, but at some point this connection is cut, so it cannot be completed. So everything is in place, as you can see on the top left window. And oops, in a moment, you will see how there is going to be it's waiting for a little bit, but it doesn't. We are actually now in our initial sleep, and in a moment it's going to go to our code and throw an exception because and assert that the exception is thrown so that we can finish gracefully. And we can see that there is the exception. And down over here, the connection is thrown, and the exception has been thrown because the connection has been closed. Okay, and this one ends our demo on network reliability. Now, the next portion, but what if we want to simulate a different network? Well, we can add ToxiProxy per different, that defines different networks, or bridge in one container for ToxiProxy, depending on what is the topology of this network. And of course, this can get pretty complex pretty soon. So it depends really on how deep you want to do. This can be a good way to start testing some basic failure situation. There was a question in the chat about are there limitations for memory, CPU? Well, of course, there is a tax that is going to get on your local hardware because you are running locally all of these components. So if these images are big, do you have enough resources? There has been, and it's in one of the link, a few years ago, a few months ago, the announcement of a test container as a service. So you can run this as a service, and so reducing, taking away the issue of like the burden on your own CPU and memory. Environment affinity. Well, the other thing that we want to talk today, it's about when we go to production, how do we ensure that the environment, the one where I'm testing, the one where I'm building my container, and the one where I'm running this container, are as much as possible close one to the other, like my runtime, my version of Java, my base of OS layer, like which are the situation where at the end of the day, like in production, this my application is going to run on. Common approach are that we can have test, build, and run environment that are usually often configured separately. So there is a test environment, then I have another place where I'm running my build, and finally I have my production environment. And maintaining all these environment in sync can be pretty difficult. There can be an upgrade to a version of one of, for example, to Java in the test environment, but not in the build environment. And so that potentially can create some disparity that at some point can kick back. Another way can be the one to use two-stage Dockerfile. These, of course, help, but because we can define, we can have control on the environment that we use to build and to run our application, and also on what's the runtime, which are the version of the libraries that we are using, but we still need to maintain the Dockerfile. So how do we scale with this approach? Well, in general, a better way is to use Cloud Native Buildpack. Buildpack, the purpose of Buildback is to provide a way to consistently build images at scale. Why? Because the build and the run stack are guaranteed to be the same. The builder is a container image that contains all of the references to build and then to point to the run image that's going to be used in production. They are polyglot, and they can be used in different ways. To the CLI, to plugin, there is a Kubernetes operator, so really a lot of choices over there. The default configuration using, for example, the Maven plugin for the Buildpack is through an environment variable where we are defining the argument for the builder. In this way, we have that our builder, the operative system, the runtime, and the operative system and the runtime of the environment where the application is run is completely under control. So we know how we are building, what we are using, and exactly where we are going to run. Now, we want to do the test. Well, the default it's so skip test. What we want to do is, well, let's do test and build using Cloud Native Buildpack. To do this, we just replace and we just change the value of the environment variable to skip test false. And at this point, also the tests are run in the same environment as the build. So to use, we can also reference what is the builder that we want to use. We can give the proper argument in order to define if we want to test, but also if we want to run a specific suite of tests inside our package. That's great. So we can use Docker, we can run our test, we can run our build, we can reference the same environment all the time. In our local machine, that's going to be the same environment because this is a container that's going to do the build that is going to use in our pipeline in our company. There is a caveat, and there was before a question also in the chat, that this means that we need to have elevated privileges, because if we need to use our Docker, we cannot just go and reference Docker socket. And specifically, this is not even possible using Cloud Native Buildpacks, because for security reason, the privileges are dropped. And so it is not definitely something, a scenario that can fly. But we can use Docker, instead of using directly the socket, we can use instead of using directly the Docker sock, we can use the socket So we can talk to the Docker daemon using TCP. To do this, and in this way, we are consistent with the restriction on not having raised privileges, so that we cannot, if we don't have raised privileges, we cannot go and open the socket, but we can do a TCP on our Docker host IP on the port where Docker is listening. How can we do this locally? For the demo that we are going to make, we are using a pretty common utility that is called socket, and it's socket cut. And what it does is that it creates a TCP socket out of the Unix socket. And this is the syntax that we are using. So we are running socket on our host, exposing, in this case, port 2375 and mapping with the Docker socket. This utility is available for Linux, for Mac, for Windows, and there are anyway also other utility that do exactly the same thing. And then we can run our pack command. So now locally, we can really simulate the same environment that we would, that our application is going to be built and then run when during the full pipeline. So we want to go a little bit farther, and what we want to check is that we want to pin for, we can pin, for example, the builder version, so that we know exactly what we are using, and also like the JVM version if we like. So there is a really fine control that we can exploit over here. Oops. And quick demo. Well, yes, we are going to run this script over here. Let me just do this. Just going this before it's to run the test again. And in this script that I'm going to start over here, yes, this is the host. This is my host. And yes, I'm running this Docker PS over here. We can verify that this gives us, let's open another window, and I'm going to do a telnet, and you can see that there is someone answering over there. So yes, we verified that we started. And now the next step, it's going to be to do a pack build using the demo2 ToxiProxy test, and we are using our Docker host through access through TCP. And we can see here all the logs for the builder phase. So the application is built. Now the test is starting, and we can see over here how that's the builder. Now we start the rehook with our application. Then all of the other, the Postgres and the ToxiProxy are run, and all the three tests are run in a sequence. And while we wait for this, it should take just, we are running this in sequence, so it's going to be a little bit faster, but still we need to wait for the 3 seconds of the timeout, and then a connection has been closed. Perfect. So we know that it's executing what we wanted to do. And we are a little bit short over here, so I'm gonna move to the last part, that is the takeaway. Well, great takeaway is that there aren't extra skills that you need to learn, like how to configure a router or other network component you don't need to do extra environment configuration. Just use test container in the environment that you know already. We are going to get an improved system affinity for our test. And it's really easy with using ToxiProxy, even to do things that we can like push a little bit the boundaries of the environment that we have. And then using the Pack CLI, we can have locally in our computer access to the same environment that it's used in our company's pipeline and in the running environment. So it's and all of this can be really done in your local machine. Here there are a few links. Specifically, this one is the one that announces the ToxiProxy as a service. And thank you very much.
Gabri, I'm back here on screen with you.
Nice.
Nice job. I just wanted to, I know that you have like zero time. So I'm just quickly scrolling through the chat. If you have a minute, we can maybe get through questions. Okay. So thanks everybody who joined. I see Scott, I see Anoop in the chat. Thanks for joining us. Scott, it's been great to interact with you on all the things this week. It's nice to see you again here. So there were some questions. I don't know if some of these have been answered. I know that there's some, for example, Scott was asking if it works with other Docker runtimes. I guess you mean like Podman or things like that. I think we got this question last time, Gabri, right? And we not that we know of. I Googled if it supported Podman at the time, and I couldn't find any evidence. So
yeah, I didn't have time to test this, so maybe we can. I don't know.
Yeah, not that
we can reach out.
Yeah. If it does, somebody asked this last time, and Podman. So I Googled when somebody asked me this last time, I Googled it for Podman to see, and there was like requests online for it to be supported, but I didn't really see any evidence that it was. So I would say, if you're interested in that, maybe try Googling it in case we missed something in our search, but we have not tried that. So that's unfortunately the best answer I can give you. Can this work with remote Docker sockets? Do you know that, Gabri?
That is like the TCP test that we did.
So that should be okay.
Of course, it depends on it can be a remote socket. We did actually that, if you recall, even using GitOps, the pipeline over there and specifying the socket. So yes, of course, there has to be a good connection.
Then there's a question Anoop is asking: is there's limitations on memory and disk space if containers are large? And
that is so I don't know about any. I didn't do a stretch test from on this perspective, but of course, depending on what you are going to run, you can run into limitations that are specific for your hardware. So that's why probably depending on the size of these images, you want to check if the test container cloud is a solution that works best.
I mean, if you think about it, the container is running on on your Docker daemon. It's so if your Docker desktop or whatever is set to have low resources, that's a problem outside of test containers.
Okay, exactly. That depends on your configuration. Maybe.
Yeah, Alexander, nice to see you too. Can you link to GitHub? Are you talking about like our test or the code that we're showing, like our demo? Or is it a question about something test containers can do? If you can tell us what the question is. Scott says, well, I guess technically if it works on Mac and Windows, it works with remote Docker sockets, as Docker desktop runs Docker socket and in the Linux VM and both. Yes.
Correct.
So like the demo we're running, right, Alexander? Is that somewhere?
Sorry?
Was our demo in the last slide of links? Project with test. Oh, can you point it to a GitHub project with? So if you have a GitHub project and your tests are checked into GitHub.
We were running that, if you recall, really at the beginning. We were writing the pipeline in Git, and we were also using test containers, referencing the Docker from Git. But I don't think we need to check if that is still if we still have that, because I remember that we made few changes, then we decided to do everything for the local. So I don't really know.
Yeah, I'm not sure. I'm not sure if I understand the question, Alexander, but if you, and you can always, if you want to find me on Twitter, you can maybe DM me the question with a little more context. And I think if I can understand the question better, we can respond to it better. Feel free to do that. And otherwise, I think that's all the questions. I hope I got them all. Thanks to everybody. Thanks also, Kripa and
It
Gab.
is in the presentation. I don't know if this presentation is going to be shared. We can definitely share with this audience. There are the links at the end. You see, Alexander.
With this project. Yeah, our test code. Yes. Oh, that, yes. Okay. Thanks. Sorry, I didn't quite know which, if you wanted to run tests that were checked in somewhere against the container. Okay. Yeah, we will, Kripa and Gabby, I hope, I assume when this is published, maybe the YouTube thing can have information about where the deck is, a link to the deck. We'll ask Kripa and Gabby to take care of that. Otherwise, Gabri, always nice to work with you. And
Same here, Cora. Thank you very much for
awesome.
bearing with me.
Yeah.
And thank you all for staying with us.
Cool. All right.
Bye-bye.
Bye, everybody.